Hello and welcome back to this channel. Dear students, today's topic is solved problems of SIF, that is step index fiber, and GIF, that is graded index fiber. These numericals are pretty simple. I have made a list of formulae. If you just memorize this formulae, you will be in a position to attempt any numerical. So first, let me brush up this list of formulae. So Na is numerical aperture, which is given as square root of n1 square minus n2 square. We know the usual meaning. N1 is refractive index of core layer, N2 is refractive index of cladding layer. Second, V number. This V number is also called normalized frequency. It is given by 2 pi by lambda. Lambda is the wavelength into A. Small a is the core radius into Na, numerical aperture. Third, acceptance angle theta A is sine inverse of numerical aperture Na. Zeta, that is solid acceptance angle, which is denoted by zeta, which is pi Na square. Then number of modes that are propagating through the particular fiber. The corresponding notation is mg. For step index fiber SIF, the formula is v square upon 2. For graded index fiber GIF, it is v square by 4. Now let us discuss one numerical. If a multimode step index fiber, it is multimode step index fiber, that is MMSI fiber, has core refractive index 1.5. Let us first write the given values. So given values are the core refractive index 1.5, that is N1 is equals to 1.5. Then cladding refractive index 1.38, so N2 is equals to 1.38. Core radius 25 micrometer. We know that the core radius is denoted by small a, which is 25 micrometer. Now do remember, the unit is micrometer. We need to convert it in terms of normal unit, that is convert it in terms of meters. So it is 25 into 10 raised to minus 6 meters. This is the value of small a. Operates at the wavelength 1300 nanometer. Wavelength is lambda, which is 1300 nanometer. Again, this value is given in nanometers. We need to convert it in terms of meters. So it is 1300 1300 into 10 raised to minus 9 meters. This is the given value of lambda. Now first part, calculate numerical aperture. As I said, these numericals are very much straightforward. So let us do the calculations. So first, numerical aperture. The formula is square root of n1 square minus n2 square. So simply you have to put the values. So it is square root of value of n1 is 1.5. I am making use of first formula, minus n2 square, that is 1.38 square. So if you solve this, answer of Na will be 0.5878. Second part, it is asked to calculate normalized frequency. Do remember, normalized frequency means V number. So we have the formula V is equals to 2 pi upon, I am talking about this second formula, 2 pi upon lambda. Lambda is 1300 into 10 raised to minus 9. So this is 2 pi upon lambda into A. A is this value into 25 into 10 raised to minus 6 into Na, value of numerical aperture. We have just now calculated this value in first part. So if you solve this, answer of V number will be 71.024. Now third calculation. Acceptance angle theta A, very simple, sine inverse of Na. So theta A, which is equals to sine inverse of Na, that is numerical aperture, which is 0.5878. So this answer of theta A will be 36 degrees. Do remember, I have written unit degrees, that means I am operating the calculator in degree mode. Fourth, solid acceptance angle, that is zeta. This notation stands for solid acceptance angle, which is pi Na square. So it is pi Na is 0.5878. So answer of zeta, this is pi Na square. So because I am making use of this formula, so pi into 0.5878 bracket square. So answer of zeta is 1.08 radians. This unit is radians. Then fifth calculation, number of modes that are propagating through the given fiber. So since it is SIF, step index fiber, the formula is mg is v square by 2. Therefore, mg is equals to v square by 2. Value of v is 71.024 square upon 2. So answer of number of modes will be 2522.2. Now do remember this value represents the total number of modes that are propagating through the given fiber. This must be integer, so approximately we can write this value as 2523. So 2523 modes will be propagating through the given fiber. Next problem. Given question is a manufacturer wishes to make silica core step index fiber with V75. This value of normalized frequency, that is V, is given as 75. NA numerical aperture 0.30 at 820 nanometer. Now this value 820 is the given value of lambda, which is 820 nanometers. Since it is in nanometers, we need to convert it in terms of meters. So it is 820 into 10 raised to minus 9 meters. If n1 is 1.458, what should be the core size? That core size means we need to calculate value of A. So core size is required, and also we need to calculate cladding refractive index, that is we need to calculate value of n2. So in the given question, na is given, n1 is given, lambda is given, and it is asked to calculate the core size, that is radius of a core layer, and the refractive index of cladding layer. First we'll do the calculation of n2. So we have the formula na is square root of n1 square minus n2 square. I will write this formula first. So I am going to make use of this formula. Why to make use of this formula? Because we are supposed to calculate n2. Na is given, n1 is also given in the question. So I am making use of this formula, square root of n1 square minus n2 square. Take square on both sides because I need to calculate value of n2. So taking square on both sides, it is na square is equals to n1 square minus n2 square. Therefore, n2 square is equals to n1 square minus na square. Simply I have rearranged the equation. This n2 square is taken at LHS, na square is taken at RHS. Then we need to calculate n2. So to calculate n2, take the square root of this. So it becomes n1 square minus na square. Now remaining part is pretty simple. You just have to put the values. So value of n1 is given in the question, that is 1.458. So it is 1.458 square minus value of na is also given 0.30. So 0.30 square. Therefore, if you solve this, value of n2, that is refractive index of cladding, will be 1.4268. This is the answer of refractive index of the cladding layer. Now remaining part, we need to calculate a value of A, that is the core radius. So make use of this formula of V number because value of V is given in the question 75. So first I will write this formula. So it is V is 2 pi by lambda A into NA. I need to calculate value of A. Simply rearrange the equation, transfer this A or transfer all the terms except A to the other side. So I will write it like this: A is equals to V lambda upon 2 pi NA. Very simple. I have kept A as it is. This entire term 2 pi NA upon lambda is transferred to the other side. So it becomes lambda upon 2 pi NA, and then LHS and RHS are interchanged. So put the values. Value of V given in the question, that is 75 into value of lambda 820 into 10 raised to minus 9 upon 2 pi. Value of Na numerical aperture, this is also given in the question, that is 0.30. So if you solve this answer of core radius will be 32.62 into 10 raised to minus 6. Its unit is meters, but it is multiplied with 10 raised to minus 6. So I can write A is equals to 32.62 micrometers. So this is the answer of core radius. Next problem, calculate the number of modes at 1.3 micrometer wavelength. This given value of wavelength is in terms of micrometers. So lambda is 1.3 micrometer, which is 1.3 into 10 raised to minus 6 meters. In GIF, graded index fiber, having parabolic refractive index profile. Now this is just for your information. The refractive index profile is denoted by alpha. If it is parabolic, value of alpha is 2. This is nowhere required in this numerical. Given A is to 25 micrometer. A is the core radius that is given in the question. So A is equals to 25 micrometer, means 25 into 10 raised to minus 6 meters. Na refractive index of core is 1.48 and refractive index of cladding, that is N2, is 1.46. It is asked to calculate number of modes at this particular wavelength in GIF. Look at the list of formulae. Number of modes for GIF of parabolic refractive index is V square by 4. Now how to think? This is the formula. First I will write this formula to be used. So I need to make use of this formula. Mg is V square by 4. To get this value, I need to know the value of V. So look at the formula of V. V is 2 pi by lambda A into Na. So I will write this formula V, which is required 2 pi by lambda A Na. Now, to calculate value of V, I have value of lambda given in the question, then A is also given, Na is not given. So I need to calculate value of Na. Na is given by this first formula. So let us first calculate Na, that is square root of n1 square minus n2 square. So simply put the values. So it is square root of 1.48 square minus 1.46 square. So if you solve this, you will get value value of Na. Then put this value in this formula of V. So it is 2 pi by lambda. So V is equals to 2 pi by lambda. Lambda is 1.3 into 10 raised to minus 6 into A. A is 25 micrometer, that is 25 into 10 raised to minus 6 into Na. Na is this value. So if you solve this, value of V number will be 29.2998. This is the value of V. Now put this value of V in the equation of Mg. So you will get V square, that is this value square, upon 4. Therefore, number of modes propagating in the given GIF, graded index cable, will be 214.62. Like the previous numerical, we discussed that this is the value, this is the number, so it must be integer. So I will write approximately number of modes that is propagating through this GIF, given GIF, will be 215. So this is the way how the numericals are solved as far as this SIF and GIF fibers are concerned. So dear students, that's it for today's session. Thank you. Thanks a lot for watching this video.